Question 2 is just recognizing one of the formulas and substituting it in. So cos squared pi over 4 minus sine squared pi over 4, that is our cos double angle formula. And so we can change this to cos 2 alpha, and the angle this time was pi over 4. So if we recognize the formula, we could plug it in, and then 2 times pi over 4 is cos of pi over 2, and that's on your pi plate. So you could figure this out. What is cos of pi over 2? X coordinate of pi over 2? It's equal to 0. Now, as far as questions go, this isn't a very good question, because is pi over 4 on your pi plate? Yes. Can you figure that out directly? It's going to be root 2 over 2, and then it would have to be squared. And then sine of pi over 4 is also on your pi plate, also root 2 over 2 squared. Without the new formula, could you have figured out this is 0? Absolutely. In fact, that seems just as easy, if not easier, than having to recognize a formula that you haven't memorized yet. Okay? So, not necessarily the best question. Same thing in B. Is pi over 6 on your pi plate? Yes. So we could already just plug things in and simplify fractions. And you've been simplifying fractions a lot with identities. So if you had to simplify fractions with numbers, I think you're getting good. Okay? However, we're going to check, does it match up with the formula? So the tan 2 alpha formula looks like this. It says 2 tan alpha over 1 minus tan squared alpha. And does this match up? No. So another reason why I wouldn't use the formula in this case, because it doesn't even match up. Can we make it match up? Yes. You notice that the top matches up as 2 tan something, but the bottom doesn't, because this one's tan squared minus 1, and this one is 1 minus tan squared. But anytime you have something where it's like backwards with the plus and the minus, you can correct it. So what I'm going to do here is I am going to take that bottom and I'm going to factor out a negative 1. If I factor out a negative 1, can you see that the 1 will become positive? And the tan squared would become negative. But now we have a problem that it still doesn't match the formula because there's a negative 1 still on the bottom of our fraction. Tiny review of negatives and fractions. If I have a negative on a bottom of a fraction, like 3 over negative 4, would you agree that that is exactly the same as negative 3 over 4? Or it's exactly the same as negative 3 over 4? It doesn't matter where that negative is in a fraction. So in this case, in part B here, what I'm going to do is I'm going to just think of that negative out in front. And at this point, I really feel that maybe it would have been quicker had we just plugged in that tan of pi over 6 is root 3 over 3 from the beginning and solved it. So with the negative outside, now this part in the green brackets matches our identity perfectly. So I could keep the negative out in front and change this to tan of 2, and my alpha is pi over 3. Or pi over 6, sorry. Getting ahead of myself. Because what happens when you multiply 2 times pi over 6? You get pi over 3. So this is just negative tan of pi over 3 and we get negative root 3 as our answer. Which is quite a bit quicker than, like, had we changed all those tan of pi over 6 to root 3 over 3, we would have had fractions inside of fractions, and we'd get the same answer. Would you like to see what it looked like if we solved it directly? So you can make a decision which one you like better? So let's redo B and just say, what would happen if you just decided, I know that tan of pi over 6 is root 3 over 3, so I'd have 2 times that, and then I had tan squared, which would be root 3 over 3 squared minus 1. This is me just plugging things in to the formula as we have them. Well, this would be, on the top I would have 2 root 3 over 3. On the bottom, if I squared this, I would get 3 over 9 minus 1. What do we do with fractions inside of fractions? We like to get a single fraction on the top and a single fraction on the bottom. So on the top, I have a single fraction already. It's 2 root 3 over 3. On the bottom, this is 1/3. And then I would think about multiplying this by 3 over 3 to get a common denominator. So 1/3 minus 3/3 would give me negative 2/3. And once I have a single fraction in my numerator and a single fraction in my denominator, I can multiply by the reciprocal. My 3's would simplify, my 2's would simplify, because it's all multiplying. And I would also get negative root 3. So I'm going to add to this, I'm going to add, and if you're running out of space, maybe you can do stuff at the top of page 655 or at the bottom of page 654. I'm going to add 2 questions to this. On the exam, it'll be more likely that you won't get these double options, and they'll give you a question that maybe looks like this. And it's non-calculator, and you temporarily have a freak out, because you're like, pi over 8? We didn't do pi over 8. What's wrong with my teacher? No. Right? Temporarily, you look at it, and there's nothing you can do with pi over 8. It's not on our pi plate. This is a non-calculator question. But this is one where they're like, we want you to recognize the formula. Do you see that 1 minus 2 sine squared alpha is one of our formulas? It is equal to cos of 2 times alpha, and the alpha would be pi over 8. And then something really nice happens, because the multiplying of fractions, the 2 and the 8 simplify. This just becomes cos of pi over 4, which is root 2 over 2. And then sometimes in math, so we got one more in this section. Sometimes in mathematics, math likes to mess with your brain a little bit. It knows how your brain has tendencies, and it wants to sort of make fun of those things. Like, you have tendencies, and this is your brain that does a great thing for all of the classes you do. One of your strategies for studying is, if I recognize a problem, I know what to do. That's how you study that way, right? You're like, ooh, it's one of these. I know how to do them, right? And when you get to a question, you're like, I don't recognize this question at all, then we get stuck and we're like, I don't know what to do. And then we have to go through a whole bunch of problem-solving techniques to get through it. So question D here, I'm going to get you to, I'm going to give you an example of where your brain can cause you to choose the wrong pathway. Okay? I'm going to get you to evaluate 2 sine of pi over 12 cos of pi over 12. And right now, your brain might not trick you because we're doing our double angle unit. But a month from now, or 2 months from now, when we're doing our exam, if this question comes up on your exam, your brain most likely will tell you, hey, that's a pi over 12. We have a whole group of questions called pi over 12 questions. Your brain will naturally throw you in that direction, okay? One of the things you also want to be aware of on an exam is how many marks a question is worth. So this one would probably be worth 2 marks. Pi over 12 questions are usually 3 or 4 marks when they're a single pi over 12. Can you see this one has 2 of them? That would be like a 6 or an 8 mark question if you did it as a pi over 12 question. So sometimes the amount of marks a question is also a hint of how much work you need to do. Okay, I don't have to do a lot of work. Then you might recognize this 2 sine alpha cos alpha is a formula. It is equal to sine of 2 alpha, and our alpha this time would be pi over 12. So if we recognize that formula instead, it is way faster than doing 2 pi over 12 questions. And then multiplying pi over 12 times 2 gives you pi over 6. And we just get 1/2. So circle questions 4, 5, and 6.